Good evening, dear students. Let's start our class now. So today we are going to discuss the continuation of our previous class, that is application of derivative. And today what we are going to discuss is the monotonicity of functions. Okay. Um, Before I start the class, could you please confirm, just couple of students, that you are able to hear my voice very clearly and able to view the screen properly, dear students? Can couple of you please
Yes, sir.
confirm? Okay, great. Thanks. Couple of confirmation is sufficient. Okay, so um, let us understand what is meant by monotonicity. Okay, the point is that let us take a function y equal to fx, and we are going to discuss that when the function is increasing and when the function is decreasing, when the function is constant, all these things we are going to discuss. And we will see, dear students, that differential calculus is going to help us to take those decisions, that whether the function is increasing or decreasing or constant, without drawing the curve of that, graph of that function. Without drawing the graph of that function, we can, conclude those. So, and here what we are going to discuss, the function is y equal to fx, right? It is a real valued function. That means it takes a real number and returns a real number. That means both x and y are a real number. So let y equal to fx be a given function with d as its domain of definition. Okay, the domain of definition is d. Then we are going to discuss few things. Is that that when the function is an increasing function. So let y equal to fx. So let me show this portion from the classroom, dear students. Look at here. Let y equal to fx be a given function with d as its domain of definition. D means it's a set. Domain of definition means in that domain the function is defined. Let d1 be a subset of d. Okay, that means it is an improper subset, as you see. Now we are going to define few things. What are the first thing we are going to define? We are going to define an increasing function. Okay, what is an increasing function? Let's look into it. Okay, first let us understand what is increasing function. Look into this one. Okay, so this is a portion from the study material. So if you see the increasing function, so in that let's understand the graph first. You see this is the x-axis, y-axis, and this is the function. When the function is increasing, means when x is increasing, the function y is also increasing. It can have like this, or it can be like this, or it can be like this, isn't it? That means the function is increasing. It could be something like this. Function is increasing. As x is increasing, fx is also increasing. That means what? Means is that x1 and x2, the way we are saying is that this is increasing, that x1 and x2 such that belongs to d1 actually, because where we are going to make that study, that d1 is a subset of d, that x1 greater than x2 is implying that fx1 is greater than fx2. Then we can say the function is increasing function. That means what? There is a certain increase in the value of fx with an increase in the value of x. Now that though whatever we have said now is that that is coming from algebra. But how differential calculus is going to help us here? So the way differential calculus is help us here is that if we find, so let me write in a different color, that if f dash x is greater than 0, okay, if f dash x is greater than 0, then we can say that fx is increasing. Fx is increasing means x is what? X is the domain of the definition. X belongs to the domain of the definition. In wherever that f dash x, that means ddx of fx is greater than 0, we can say, fx is an increasing function. Okay, we'll see examples. And for example, if I give a function called fx equal to x cube, okay, if fx equal to x cube, then what is f dash x, dear students? F dash x is equal to 3 into x square. You see, dear students, as x is increasing, definitely x square will also increase. More than that, we can say whether x is negative, positive, always f dash x is greater than 0. Correct or not? Fx is greater than 0 except x equal to 0. That is a special case. So we see, for all x, okay, we see that f dash x is greater than equal to 0. We can say, especially one case, we can say it is 0. So then we can say fx is an increasing function. Correct or not? So this is one example of an increasing function. So when you get that function fx equal to x cube, dear students, one thing you notice, we have not drawn the graph of fx equal to x cube. If someone gives me a graph of fx equal to x cube, just by inspecting the graph, we can say whether it is increasing or decreasing. And that is the significance of differential calculus, that without having the graph of that corresponding function, we can tell whether the function is increasing or not. What is that? If f dash x is greater than 0, then we can say fx is increasing. Correct, dear students? I hope all of you understood this particular point. Now, the next one, what is coming is that it is a non-decreasing function. Okay, non-decreasing function means what? When x1 greater than, let me first, place the class note here. Non-decreasing function means is that, that if x1 greater than x2, that implies fx1 greater than equal to fx2. You see, dear students, here there is a greater than. Okay, let me use a different color. Here, here we get a greater than, correct? And here you get greater than equal to. Notice the basic difference. But in the previous case, what it was? It was x1 greater than x2, and we got fx1 greater than fx2. Correct, dear students? So here what we are going to discuss is that non-decreasing function. So the difference between increasing and non-decreasing is that only that greater than equal to. So that means what? x1, x2 belongs to the domain of the definition of the function d1. x1 greater than x2, implying that fx1 is greater than equal to fx2. Then we can say that it is a non-decreasing function. And you, dear students, that as long as the differential calculus is concerned, how we are going to define? If f dash x is greater than equal to 0, that implies fx is non-decreasing. Fx is non-decreasing. Correct? Now, we will see example. In fact, the previous example what I gave, fx equal to fx equal to x cube, it is actually a practical example of a non-decreasing function. Okay, it is increasing, but there is a special case where it is actually equal to 0. That is why it is non-decreasing function. I will come to this terminology also sometime. Let me discuss about these terminologies. Not the only one terminology is being used. So let me explain you by means of a different color, dear students. Okay, let me use this card. Is that for every x1 x2 belongs to D1, if x1 x2 belongs to D1, x1 greater than x2 implies, it can imply two things, that fx1 is greater than fx2. Then sometime it is also known as strictly increasing function. Okay, it is known as strictly increasing function. Why it is so? Let me explain you. Strictly increasing function. And if you see that fx1 is greater than equal to fx2, then we can say, either we can say that increasing function, either we say it is an increasing function, or we can say the non-decreasing function. Non-decreasing function. These are the different terminologies used. Fx1 greater than fx2, sometimes we can say this is an increasing function also, instead of strictly increasing. These are the statements actually being used in different books follow different way of definition, okay, of this thing. But fundamental thing you should understand, one point, dear students, is that let me explain you by means of the graph so that it will be very clearly understandable. Okay, what is that? Let me draw the graph first. Okay. If I draw the graph, let me first draw the coordinate axis. Suppose this is the x-axis, okay, and this is y-axis. So this is x-axis, x dash, y dash. This is origin. See, when it is in strictly increasing function, so let me draw the strictly increasing function in green color, for example. That means strictly increasing function means like this. As x is increasing, fx is continuously increasing. That is strictly increasing function. Okay? But that is known as the strictly increasing function. So we can define this as a strictly increasing function. Now, dear students, you get another case. Let me use the purple color. Suppose a function is something like this. It goes something like this, then go along a straight line. This is a straight line, and then again this one. This kind of function, we call it as a non-decreasing function. Non-decreasing function. Non-decreasing function. So when we say that this blue color, that strictly increasing function, then we can say the purple color function as increasing function. If we say the blue color as a strictly is an increasing function, then we can say the purple color as a non-decreasing function. Why non-decreasing? That means it is not actually decreasing. It can be constant in this period of time. If you look into this particular one, this particular region, you take two values. Suppose you take this one is x2 and you take this one is as x1. So what do you get? x1 is greater than x2 now, but fx1 is equal to fx2, which falls into this category. And we can either say it is an increasing function or we can say it is a non-decreasing function. It depends on what kind of terminologies we are using. So these are the fundamentals you will understand, dear students. Okay, because different books follow different way of definition. Okay, this thing. These are the fundamentals. So now, when it is a non-decreasing function, what we get is that f dash x is greater than equal to 0. Correct, dear students? I hope it is clear. Next one, what we are going to discuss, dear students, is called a decreasing function. Okay, so what is decreasing function? Let us understand. Okay, so let me take you to the next page and explain you about the decreasing function. Decreasing function, by the way, dear students, it is the the reverse of the increasing function. You see that as x is increasing, that as x is increasing, if we carve like this, as x is increasing, that fx is actually decreasing, or something like this. As x is increasing, fx is decreasing. That means what? That means x1, x2 belongs to d1. Okay, x1 greater than x2, implying that fx1 is less than fx2. Okay, then what we can say? We can say this function is a decreasing function. Okay, but how differential calculus is going to help us here, dear students? The differential calculus is going to help us like this, that if we find that f dash x is less than 0, that implies fx is decreasing. Okay, so there are many examples where the function is decreasing. Okay, we will see as time goes by with example, but only point is that without having the graph of that function, just by finding the differential coefficient of fx with respect to x, if we find that f dash x is less than 0, then we can absolutely say the function is a decreasing function. So decreasing function means what? That there is a certain decrease in the value of fx with an increasing in the value of x. That's what we are seeing. That x is increasing in the entire path. If you see, x is increasing, but fx is decreasing. Here also, x is increasing, okay, but fx is decreasing. In this one also, the straight line coming down, x is increasing, but fx is decreasing. All these are decreasing function, dear students. Okay. Then the next one, what we are going to discuss is that non-decreasing function. Okay, so let me take you to the next page and explain you about the non-decreasing function. And let me first take you to the and dear students, whatever you see some watermark in the background, this is actually from the study material of konarclasses.com. So that is why there is a watermark you see in the background. So what is non-increasing function, dear students? If you see the classical graph, whatever I have shown here, is that that x, as x is increasing, fx is decreasing, and sometimes it can be constant also. I explained few minutes back in the other graph actually with respect to the non-decreasing function, and again it is non-increasing, means coming down. So that means non-increasing means is that at any point of time you will never find that x is increasing, but fx is also increasing. Fx can be at most constant or coming down. That means what, dear students? What you can write for non-increasing function? x1, x2 belongs to d1, and x1 greater than x2 is implying that fx1 is less than equal to fx2. Then we say it is a non-increasing function. In the similar manner, how differential calculus is going to help us here, dear students? So if we get, if f dash x is less than equal to 0, this implies fx is non-increasing. If f dash x is less than equal to 0, then you can say fx is non-increasing. So what non-increasing function tells us? Non-increasing function tells us the value of fx would never increase with an increase in the value of x. That is called non-increasing function, dear students. Now the next one is coming is that neither increasing, non-decreasing, nor decreasing function. What kind of function it could be? Let me show you. Okay, and it will be so that you will understand what is the meaning of such a function which is neither increasing, non-decreasing. As you see, dear students, in that in the adjoining graph, here what we see, dear students, is that the fx, the function is sometime increasing in this region to this region. After that it is again decreasing in this region, then again it is increasing in this region. So into the entire domain of definitions, from starting from here to here, we cannot say the function is increasing or decreasing. Sometime it is increasing, sometime it is decreasing. From where to where it is increasing? From this position to this position it is increasing. Suppose if we say it is a called x1 to x2, it is increasing. Then again from x2 to x3 it is decreasing. Again from x3 to x4 it is increasing. So from x1 to x4 we cannot say whether the function is increasing or decreasing. So that's why it is called neither increasing, non-decreasing function. Correct, dear students? So what will happen? So how differential calculus is going to help us? Here you will see from x1 to x2 f dash x would be greater than 0. Then again from x2 to x3 we will get, so in this region what we get, f dash x is greater than 0. So let me use a different color. Okay, from x1 to x2 you will find that f dash x is greater than 0. Then from x2 to x3 you will find f dash x is less than 0. Then again from x3 to x4 you will find f dash x is greater than 0. So that's why differential calculus is going to help us here. Now the next point we are going to discuss is that it is a constant function. Okay, so constant function, what is constant function? Let me first show you, dear students, and after that I will explain in details. So as you see in this adjoining diagram, the constant function is something like this, that when x is increasing or decreasing, fx is not changing at all. That is why it's called constant, right? You see, if you look into this adjoining diagram, here you see that x is, suppose this is x2, this is x1. So what do we see? x1 is greater than x2, but fx1 is equal to fx2, correct or not? So x1, x2 belongs to the domain of definition D1. x1 greater than x2 is implying that fx1 is equal to fx2. So then we can say the function is constant in that domain. Now, how differential calculus is going to help us? You recall, dear students, when you studied the differential calculus, that we understood one thing: if constant differentiation of constant is 0, isn't it? ddx of 5 is 0, ddx of k is 0, where k is a constant. So in that so we can from there we can say that if f dash x is equal to 0, that implies fx is constant. That means what? So what we can say about the constant function, that the value of fx, the fx will be fx qualified to be a constant function if the value of fx would remain constant with an increasing in the value of x. Then we can say it is a constant function. And in the similar manner we can say in the decreasing of x also. Anyway, means that fx doesn't change. You see, this is a straight line. Fx doesn't change, it is a straight line, so that is why it is a constant function. So what we have discussed so far, dear students, we discussed about the increasing function, then we discuss about the non-decreasing function, then we discuss about decreasing function, then we discuss about non-increasing function, then we discuss about neither increasing nor decreasing function, and then finally we discuss about the constant function. And in every aspect I told you that how differential calculus is going to help us. Now I just want to give you the complete snapshot of whatever I have discussed, and then I will discuss about the basic theorem on the monotonicity. So and I'm going to discuss all these things in the next page, dear students. Okay, let me take the portion of the study material, and then let me explain. So what is the definition of monotonicity of a function at a point? So let x0 be a point in the domain of definition of a real valued function fx. Notice this particular point, dear students. Let x0 be a point in the domain of definition of a real valued function fx. Now, fx is said to be increasing, non-decreasing, decreasing, non-increasing, or constant at the point x0 if there exists an open interval I containing the point x0 such that fx is increasing, non-decreasing, decreasing, non-increasing, or constant respectively in that open interval I. So whatever the statements I have mentioned here just now, dear students, let's give a mathematical formulation. So that means let there exist an interval I, x0 minus h, comma x0 plus h. If you look into this interval, this is surrounded by x0, sorry. This interval x0 minus h, comma x0 plus h, open interval because it is the first bracket, open bracket. That's why it is an open interval. So what we see, dear students, is that in this open interval, what we get is that it is surrounded by x0. Okay, now for h greater than 0, we are taking. Let x1, comma x2 belongs to that open interval I. We define that open interval I as x0 minus h, comma x0 plus h, or h greater than 0. And we are taking x1 and x2 belongs to I. Now a definition, now the function fx is said to be an increasing function at x0 if and only if x1 greater than x2 implies fx1 greater than fx2. Non-decreasing function at x0 if x1 greater than x2 implies fx1 greater than equal to fx2. A decreasing function at x0 if x1 greater than x2 implying fx1 less than fx2. A non-decreasing function at x0 if x1 greater than x2 implying fx1 less than equal to fx2. A constant function at x0 if x1 greater than x2 implying that fx1 equal to fx2. That is the fundamental definition of monotonicity of a function at a particular point x0. Now, dear students, what I am going to discuss is that some basic theorem on monotonicity. I explain those things a little bit during the definition. So I'm going to give you just summary of that one. That's some basic theorems on monotonicity. So let me discuss all these things in the next page. Okay, so look into this particular portion of the study material, dear students. Let y equal to fx be a function continuous in the closed interval a comma b, and differential in the open interval a comma b. I repeat, dear students, let y equal to fx be a function continuous in the closed interval a comma b and differentiable in the open interval a comma b. Then the following statements hold true: that fx is increasing in the closed interval a comma b if f dash x greater than 0 for all x belongs to the open interval a comma b. I hope you are able to get this point because I discussed this point during the discussion of all these functions. Okay, in the similar manner, dear students, that whatever I am going to get in the other definition, let me show you, dear students. So here it is. The next one is that fx is non-decreasing in the closed interval a comma b if f dash x is greater than equal to 0 for all x in the open interval a comma b. Third one is that fx is decreasing in the closed interval a comma b if f dash x is less than 0 in the open interval a comma b. Fourth one is that fx is non-increasing, in the closed interval a comma b if f dash x is less than equal to 0 in the open interval for all x belongs to the open interval a comma b. And finally, fx is constant in the closed interval a comma b if f dash x equal to 0 for all x belongs to the open interval a comma b. So this is, one of the fundamental, theorem on monotonicity. Now, from here we can say few more things. That what are the few more things? Let me show you one by one, and then you'll understand this thing. The first point what I'm going to say is that let me show you this first 3 points, then let me explain it. So here it is to be noted the following, dear students. Number one, if f dash x is greater than equal to 0 for all x belongs to the open interval a comma b and points which makes f dash x equal to 0 in between the open interval a comma b do not form an interval, then fx would be increasing in the closed interval a comma b. In the similar manner, dear students, if f dash x is less than equal to 0 for all x belongs to the open interval a comma b and points which make f dash x equal to 0 in between the closed interval, in between the open interval a comma b do not form an interval, then fx would be decreasing in the closed interval a comma b. If f0 equal to 0 and f dash x greater than equal to 0 for all x belongs to R, then what we can say, dear students, fx is less than equal to 0 for all x from -1 minus infinite to 0, and fx is greater than equal to 0 for all x from 0 to infinite. So this is one conclusion we can make. In the same line, there are some other statements which I am going to make, here. And here you see, dear students, if f0 is equal to 0, if f0 is equal to 0 and f dash x is less than equal to 0 for all x belongs to R, then fx greater than equal to 0 for all x belongs to minus infinite to 0, and fx is less than equal to 0 for all x belongs to 0 to infinite. We will all see all these things by means of examples in later. A function is said to be monotonic if it is either increasing or decreasing. These are the terminologies. I repeat, dear students, a function is said to be monotonic if it is either increasing or decreasing. The points for which f dash x is equal to 0 or f dash x does not exist are called critical points. Okay? The points for which f dash x equal to 0 or f dash x does not exist are called the critical points. Please note that the critical points are interior points of an interval. And later when we will discuss about the maxima and minima, then we will see, that critical points plays a very vital role in during the finding the maximum and minimum value of a function. And the next one is that the points where f dash x equal to 0 in the domain are called the stationary points. Okay, so these are the different terminologies, dear students. Now, what I'm going to do, in this monotonicity of functions, I'm going to discuss, couple of problems with you, so that you also open your notebook, dear students, and we will see how we can, how we can apply the concept, of differential calculus to, to find the values of x when a function is increasing or, decreasing. So, so here is the question. Let me take you to the next page and explain you about this question. So the question is that, dear students, is that find the values of x, find the values of x for which the function fx is, first we are going to discuss increasing, okay, and then we are going to discuss its decreasing. One thing, let me tell you before I proceed. If someone gives you the graphical representation of this function fx, that is fx equal to 2x cubed minus 21x squared plus 72x plus 30, then without doing any, without having any knowledge of calculus, you can say whether the function is increasing or decreasing. But when the graphical representation of this function is not given, which is the practical case, when the question will be given to you, no graphical, representation will be given. It is a raw algebraic function is given in front of you, like what you see, fx equal to 2x cubed minus 21x squared plus 72x plus 30. And by using the differential calculus, you need to tell whether the function is increasing or decreasing. So first and foremost, what we need to do, dear students, we need to find f dash x, correct or not? So what is fx here, dear students? Fx is equal to 2x cubed minus 21x squared plus 72x plus 30. So from here, what we are going to find, dear students, is that f dash x. So if we find f dash x, means if we differentiate, with respect to x, so then we get in the right hand side 6x squared minus 42 into x plus 72. Okay, so now that implies, we can write f dash x is equal to, we can take 6 common, and we get 6, if we take 6 common, x squared minus 7x and plus 12. And then this, polynomial expression, that x squared minus 7x plus 12 can be, factorized further, and it is like x minus 3 into x minus 4. Now, we need to find when the function is increasing. Okay, so let me discuss first about the increasing function. This is a very, important, information, that f dash x is equal to, f dash x is equal to 6 into x minus 3 into x minus 4. Now, first we are going to study about the increasing. So the moment we are going to study about increasing means what, dear students? What we learned? F dash x should be, greater than 0. Now, f dash x is greater than 0 means what, dear students? Just a minute. F dash x is greater than 0 means what? This implies 6 into x minus 3 into x minus 4. Sorry, right, let me write properly. X minus 3 into x minus 4 is greater than 0. Now 6 is a positive number, so we can ignore, means we can, cancel it from the both sides of the inequality. As it is a positive number, then sign of inequality doesn't change. X minus 3 into x minus 4 is greater than 0. Now, dear students, we need to apply the concept of linear inequalities, what we have learned in the last year. So if x minus 3 into x minus 4 is greater than 0, then what we can conclude, dear students? That either x is greater than 4 or x is less than 3. From where it is coming? It is coming from the linear inequalities formula, dear students. If you remember, let me just give you a information x minus alpha. It is all these linear inequalities video lectures are available in the online platform at konarclasses.com, also available in YouTube. Go to YouTube, just give Konar classes linear inequalities, you will get a series of lectures. So when we see x minus alpha into x minus beta greater than 0, that from linear inequality, our linear inequalities knowledge tells that means either x greater than maximum of alpha and beta, or x less than minimum of alpha and beta. Now if we apply this concept, so here alpha and beta are 3 and 4 respectively. So x minus 3, x minus 4 greater than 0 means what? Either x is greater than maximum of 3 and 4, that is greater than 4, or x is less than minimum of 3 and 4, that is x less than 3. Correct, dear students? So this is an increasing function. So what we can say? We can say that x belongs to 4 to infinite union minus infinite to 3. Correct or not? So we can write in a more perfect manner, in a sequential manner, is that implies x belongs to minus infinite to 3 union 4 to infinite. So these are the values of x for which the function fx as given in the question is an increasing function. I hope it is clear, dear students. Now we are going to discuss about that decreasing function. When the function is going to be decreased, that means downward. That means when when the function is when x is increasing, fx is actually decreasing. Okay, let's see how we can find it out, dear students. Okay, so to analyze the decreasing one, let me use a different color. Okay, so let me use a color, green color, let me use. Okay, so we are going to discuss about the decreasing. Now to discuss about the decreasing function, so what has to happen, dear students? F dash x has to be less than 0. So you already found it out. What is f dash x? F dash x is equal to 6 into x minus 3 into x minus 4 is less than 0. That means what, dear students? As 6 is a positive number, we can cancel 6 on the both sides of the inequality, and sign of inequality will remain same. Means less than will remain less than, because 6 is positive. That implies x minus 3 into x minus 4 is less than 0. Now again we need to go back to our knowledge in our understanding in linear inequalities. So let me show you that whatever I am just, this is one information I showed you now, that is actually coming from the linear inequalities. Similarly, another point is there. I am using the same color here, dear students. So x minus alpha into x minus beta, if it is less than 0, that implies what? That implies what, that implies that x is in between the alpha and beta. That means minimum of alpha and beta less than x less than maximum of alpha and beta. That means minimum of alpha and beta less than x less than maximum of alpha and beta. So this is also an information actually we are getting from the linear inequalities which you have learned earlier, dear students. So now what we are going to get here, if we apply that concept here, dear students, so what we are going to say? We are going to say from here, what we say is that 3 less than x less than 4. That implies x belongs to the open interval 3, 4. So when x belongs to the open interval 3, 4, the function fx as given in the question is an decreasing function. And what you found earlier, which is there in the blue color, dear students, that when x is from minus infinite to 3 or from 4 to infinite, we can say the function is increasing. That is well understood, dear students. I hope it is absolutely clear. Okay. Now, in the similar manner, we can solve the other questions, that how you can find in the function is increasing or decreasing, and and that will actually help you to find when the function is increasing. Okay. Now, uh, now what I want to show you, dear students, is that how to appear the daily practice problem and the unit test question, the practice test questions in the online platform at konarclasses.com. So for that, what I'm going to do, dear students, I'm going to share you a different different website, different I'm going to share one website with you, that is konarclasses.com. Okay, and I'm going to just give me a few seconds so that I can share the screen with you. Okay, and solving problem from this platform will help you a lot. Okay, so I hope all of you are able to view that konarclasses.com website. Could you please confirm, couple of you, that you are able to view it or not? www.konarclasses.com. Can couple of you please confirm whether you are able to view it or not, dear students?
Yes, sir.
Able to view. Okay. Okay. So then what you need to do, dear students, is that once you come to this website, so it is www.konarclasses.com. Once you come, then it is www.konarclasses.com. Then after that, you need to click into the login. Okay, and then you give your login. So I'm giving a demo login. All of you have login, I hope. Okay, if someone of you do not have login, please do contact me. And after giving your login and password, what you are going to do is that you can go to the right online examination. Go to right online examination, and then here click with application. You see application of derivative started coming. So you click here, then view paper details. So here the information is giving, dear students, please note the following points before appearing this paper. All the questions are mandatory. And second one is that the time duration for this test is 2 hours. Please note that in this test, how much marks you are getting not important, is not important. It is important how well you understand the concepts during learning and how well you are applying this concept in solving these questions. Happy testing with best wishes, Team Konar classes. After that, you click on write test and you start getting the questions. Dear students, at this moment you are learning about application of derivative. So you may make mistakes, but here we are to help you with this mistake. How? You see, all these questions are descriptive questions, right? So you need to write answer in your in your paper. Okay, that answer paper, whatever you have, it may be 5 to 10 pages of document. Then you scan all those pages, make a single file, PDF file, or JPG file or PNG file or a zip file. There are a lot of applications available to scan it. Okay, so then after having this scan copies of your answer paper, you can upload that answer. You see here, upload. After uploading, successful uploading, you can submit that paper, and then it will come to our faculty members. So your descriptive paper, what you are actually uploading from your home, is getting evaluated by some of our expert faculty members. Okay, and once that evaluation is done, then the evaluated paper is also available to you. Faculty will evaluate. Faculty will, after evaluation, the faculty member will upload the evaluated paper into the website, and you will get an email notification to download your evaluated paper. So understand, dear students, by sitting in home, you are getting your descriptive paper evaluated. Correct? That is all about the how you can write the DPPs. So I'm now cancelling this paper because I'm not going to appear that one. Then you come to write practice test. After that, what you are going to do, dear students, is that you are write application of derivative. Just write application of derivative and then write practice test. So here you will see these are the good quality questions, up to the level of, Karnataka CET, BITSAT, JEE Main, and other state level engineering entrance examinations. So you start answering this question. Suppose this answer A, this answer B, this answer A, this answer you give D. Question number 5, suppose you do not know, do not answer. Question number 6, you give A, then you give B. Suppose question number 8, you give B. Question number 9, you give C. And question number 10, again, you are not aware of. Once all these questions are answered, then you click on submit paper. Then what you give is that correct answer 0, non-attempted 2, wrong answer 8, total marks 10, marks score is 0. So that means none of the answers are correct. Then what you can do is that you can perform your self-assessment, dear students. That, for example, first question, correct option is C, but I choose A. Then there are two questions being asked. Read the question. I say it is a hard question. And why it got wrong? We understood that a question get wrong because of 4 reasons. Either did not study relevant theory, or concept was not clear, or it is a silly mistake, or did not remember formula. Okay, suppose it got a concept was not clear. So then what happens, dear students, our computer system, our software technology is actually remembering that for this particular kind of students, this kind of questions are actually where the concept is not clear. So when you start appearing many tests on application of derivatives, the computer system generate a pattern using latest technologies called machine learning and artificial intelligence. Okay, and with this you will know by means of a report that how things are actually progressing. Similarly, for the second question, why it got wrong, and you can write concept was not clear. Third one, you see it is hard and it was a silly mistake. And any moment of time, if you have any query on any question, you can just click on submit query feedback. Then one window will pop up. There you write whatever your query is, and then you click OK. Then what will happen? One email will come to us that this particular student raised a query on this particular question. Then our faculty member will be in touch with you to help you to understand that particular question, how to solve it, and what are the doubts you might have. In that way, you start, this is called the self-assessment. So it is a moderate, did not study relevant theory. Question number 5, remember, question number 5, we didn't attempt it, right? So first it is asking, read the question. Suppose I say hard. And then it is asking, why not attempted this? For other questions, it is asking why it got wrong, because I attempted and it got wrong. But here in the question number 5, what happens is that I didn't attempt. So then it is asking, why not attempted this? So when a student didn't attempt a question, there are 3 reasons behind it. Either did not study relevant theory, or concept was not clear, or did not remember formula. Suppose in this case, it was concept was not clear. Then come to the next one, it is moderate, silly mistake. Next one, it is very easy, but it got wrong because I didn't remember the formula. Next one also, suppose it is easy, but a mistake happened due to silly mistake. Question number 9, it was hard and did not study relevant theory. And question number 10, again, if you recall, we didn't attempt that question. So it is first asking, read the question, that is moderate, and why not attempted this? So I'm saying concept was not clear. Once it is done, then I click into the submit self-assessment. Then what message is coming from the online test platform, dear students? Your self-assessment submitted successfully. Your self-assessment will help us to guide you for a better preparation in more effective manner. We leverage artificial intelligence and machine learning extensively to make your learning and preparation more effective. So, dear students, you understood by now that how that by appearing more and more tests in the online test platform at konarkclasses.com can achieve you a great result. With this note, I would like to conclude the class for today, dear students. In our next class, what I am going to discuss is that I am going to discuss maxima and minima. So I come back to my digital screen again. So And from next class, we will be discussing the maxima and minima, and that will take a couple of classes to work on that. So with this, I would like to conclude the class unless you have any specific question for me. Thank you very much, dear students.
Thank you, sir.
Thank you.
Thank you, sir.
Thank you, Prajwal. Thank you very much.